If you've ever created an amortization table in Excel, it probably looks something like this. There's 6 columns, one for period, beginning balance, payment, interest, principal, and ending balance, along with some inputs for your amortization table. Each column has its own formulas, and if you've done it right, at the end of the table, your ending balance should be 0. Today, I'm going to show you a new way to make an amortization table using the LAMBDA function in a user-defined function that I've created here called AMORT. So AMORT here, I'm going to set our interest rate here to 5% divided by 12 to reflect a monthly interest rate, our number of periods here, and the loan amount as a negative value, along with some optional arguments that I'll cover later. With that, just one formula, we're able to create an amortization table on the fly, just like that. Let's dive into exactly see how this formula works. There's a link in the description for a download of this file so you can follow along. We're going to move over to the AMORT LAMBDA page. We're going to expand this formula bar so we can see what's going on. This is the code behind that AMORT function that's been stored in the name manager. If you're not familiar with LAMBDA, LET, some of these other bigger functions, I will be making videos in the future to cover those. Please let me know in the comments below which functions you're having a hard time with and which ones you'd like to see covered more in the future. So starting off with LAMBDA, LAMBDA of course takes parameters or calculations. Of course you set your parameters first and then you end with a calculation. So here we're setting 3 non-optional, so required parameters, rate, the number of periods, and the present value of the loan. And then we have 6 optional arguments, one for headers, one for totals, one to round the output, and then some qualities of the loan, so interest only term, balloon payment, or equal principal payments. That's what the EPP stands for there. After that, we're going to have the entire calculation of the loan be kind of nested in this let function. So let we're going to use let to kind of just organize our thoughts here and simplify some of the math, stuff like that. So the first parameter of let is header. Here we're going to just create headers for our table. This is going to be one of the optional arguments, as you can see here in LAMBDA. If the user chooses headers, then we're going to throw headers in their output. Next, we're going to define that first row of the table. So since we're starting in period 0, we want 5 zeros from period all the way to principal, and then we just want the total amount of the loan there in ending balance. So that's what we're doing with hstack and sequence. Sequence is just spitting out 5 zeros, and hstack is combining that with the total balance of the loan. Next, we are defining interest only term. So this is one of the features of the loan that you can set here. If you want to create a loan that for the first n number of periods has their payments only be interest and nothing going towards principal, then you can set that in the interest only term of the optional argument here in the LAMBDA. So here we're just checking, is that input omitted? This is a new function for lambdas, just checking to see, did the user enter anything for that interest only term? If they did not, rather, this first value if true, we're just going to set interest only term to 0. If they did, then we're going to take that interest only term and set int ot, interest only term, to that input from the LAMBDA. Next, we have balloon payment. This is another potential feature of a loan. It's kind of represents a loan that is amortizing over a longer period, where the total balance of the loan is due before that amortization is up. So this here is set just like the interest only term. We're just checking, is it omitted? If it is omitted, then we're taking the number of periods to say we're just going to pay it off in the total amortization period. Or if it's not if it is set rather in the Lambda, we will set our balloon payment equal to what the input was there in the Lambda. Next, we're going to set our payoff term. So here, we're just saying which number is lower, the number of periods from the Lambda or the balloon payment, and that's just going to set our total number of periods in the table. Next, we are creating an array of numbers for our period. So here we're doing that with a sequence function, and we're just taking that number that we just set in payoff term and blowing that out to how many ever periods we have. Note we're not starting at 0 because our first row here already includes the 0 period. So when we stack all this together at the end, we just don't need 0 here. We'll start with 0 in the first row and then go from 1 in the period. The next few names here in let are to do with principal. So we're going to start building our principal column since that's kind of the core of our amortization table. The first two are setting the equal principal payments. So if that is chosen, an equal principal payment loan is one where every payment is the same amount of principal and the total payment is going down over time as your interest decreases. That's contrary to just a standard amortization, which is noted down here with standard principal. In a standard loan, your payment stays the same and your principal your principal increases over time and your interest decreases. So to set the equal principal payments principal amount here, we're just going to do a sequence. The number of rows that we have is going to be our payoff term. And then the amount here, we're just going to check, is the period that we're in before or equal to the interest only term? If it is, we're not going to be paying any principal, so that's going to be set to 0. If it is after that term, we're going to take the total amount of the loan divided by the number of terms of our loan, number of periods of the loan, minus our interest only term. So it's just going to be equal principal over the life of the loan. And then important piece on sequence, we're going to step by 0. We don't want that to increase over time. It's just going to be that amount. Next, we're going to be setting a cumulative equal principal payment. Here we're going to be using the scan function. This is another new nice function in Excel. It's kind of a Lambda helper function, and it's kind of an accumulator. So what we're going to do here with the scan function is we're going to start off with 0. We're going to give it the array of all of our equal principal payments. And what we're going to say is for each one of those rows, go row by row and start at 0 with these equal principal payments. Add on for each period so that we know by each period how much we've paid in cumulative principal payments. Next, moving on to standard principal, we're going to check here if the period is equal to or less than the interest only period, then we're not going to be paying any principal again. Otherwise, we're going to use this PMT, which is a function to return the principal payment in a normally amortizing loan. And then all of our inputs, really just what we've set in the Lambda function up here, or our let names. So here we're using rate from Lambda. And then in the period number, we are checking, we're using this period array that we've set up here, minus the interest only, because again, we're not paying interest in those first interest only periods if we've set that. The total number of periods is NPER minus interest only, and the total amount of the loan is that PV. To accumulate the standard principal amount, we're going to use scan again, same way that we've just used the equal principal payment for cumulative. Scrolling down here a bit, we are going to set our balloon payoff amount if that's been set by the user. So here we're checking, is the period equal to the balloon payment period? If it is, then we're going to calculate our balloon payment. If it's not, then we're just going to return a 0 because there's no balloon payment. So how we calculate the balloon payment is we take our total loan amount and we subtract our cumulative principal that we've paid so far based on which principal payment type we've gone with in this loan. So if the EPP set by the user was equal to 1, meaning that that was that type of loan, then we're going to use the cumulative EPP principal. Otherwise, we're going to use the standard. And we're going to return that array, and we're going to kind of have this nested here in the choose rows function. So this choose rows function is going to take that array, and it's going to say, all right, go to this row number and choose that row. So that row number is going to be the balloon payment period minus 1. So whatever period that balloon payment lies in, we're going to want to pay off the principal in the next period. So that's why we're moving back 1 period there. So the balloon payoff amount, that will return the total principal that we need to pay to pay off the loan if that balloon payment has been chosen. Next, we have principal name. So here, we're just going to accumulate pretty much everything that we've just set up here in each one of these principal names to show kind of a final principal payment that we're going to eventually add into our table here. So we're just checking if the period equals the balloon payment period, then we're going to want to return our balloon payoff, that amount. Otherwise, we're just going to return our normal principal schedules here, depending on if we're EPP or not again. So principal is this kind of final principal column here. Ending balance, we want to use scan again to accumulate based on our original loan amount and how much principal we've paid. So our original amount is that 20,000, and the array that we're using is the principal that we just set here. And for each line, we're going to take that original loan amount and subtract each principal. So we're going to decrease that principal over time in the ending balance. Beginning balance is going to look at ending balance and kind of stack together with that ending balance shifted down 1. Because of course, if you can see in our table here, that's exactly what ending balance is. It just directly relates to beginning balance, just shifted down 1. So we're going to use the vstack function here. Since this 20,000 is not actually sitting in our ending balance name here, that's again the first row that we've set earlier in the let function. We're going to use vstack, and we're just going to start with the beginning balance of the loan, since we're starting here in this row 1. And we're going to stack that on top of the ending balance array here, except we're going to drop that last row. So drop here another new function that takes an array and removes rows or columns from that array. So with a -1, we're going to be removing the last row of that array. So we're going to be taking, for example, this 18,927 and down, and then removing the last row at the very bottom. And we're just going to be tacking it onto the array here with the beginning balance of the loan. Now we're through just about all the difficult part of this formula. Now we're just kind of doing some easy math and combining of everything that we've just created. So interest is just the beginning balance times our rate, and again the rate set in the lambda. Payment is our interest plus principal. That's pretty simple. That's your total payment. Our totals row, again, that's just an option down here at the bottom. If we want to see our total payment, interest, and principal, we're going to accumulate this just like we did for the first row where we used hstack. We're going to use hstack, and we're going to do first total. You can see that's in that first column there, total. And then next is 0. We don't really want a total for beginning balance. And then the next for payment, we're just going to sum payment, and then the next sum interest, sum principal. We're going to wrap all of those in rounds just to get these equal to or to the nearest penny. And again, the rounds here don't affect any of the math above. It's just rounding in this total line. And for the last column, we're going to do 0 for ending balance. Next, we're going to start accumulating everything that we've just created. So initial data, we're going to do this in a few steps to accommodate some options that we have in our Lambda. Initial data is going to use vstack and hstack. First, we're going to take our first row at the very top using VStack, and we're going to stack something below it. The thing that we're going to stack below it, kind of nested here, if you can visualize, we're going to use HStack, and we're going to HStack each one of these columns that we've created: the period, the beginning balance, the payment, the interest, the principal, and the ending balance there. So at this point, what we're going to be looking at is just the numbers of our total table here, from period 0 all the way down to 18, all the way over to ending balance. Now with initial data, after that, we're going to move to just data here. And we're going to check, did the user want all of these numbers here to be rounded? We have this option for round output. If they did want it to be rounded, then let's go ahead and just round everything in that initial data to the nearest penny. Otherwise, just return initial data. Note here that because all the interest and all of the calculations have already been done at this point, the rounding won't affect any interest calculations in the past. It's just going to round the final output. Next, data with headers. So again, check, did the user want headers here in this optional argument? If they entered a 1 for yes, then let's go ahead and VStack our header that we created at the beginning of the Lambda. Let's VStack that header with the data that we just created here. Otherwise, if they didn't want the headers, let's just return data. Next, we're going to do data with totals. So if the user wanted totals, this total is just coming from Lambda. Let's go ahead and VStack what we just created in data with headers with the totals row. And otherwise, if they didn't want those totals, leave it out. Just do data with headers. And now at the very end, what we're going to return is just data with totals. So since we've gone down the line and added in each option that the user wanted, the returning result here is going to be this table. So of course in the Lambda function, if you haven't named it yet, you can put the variables at the end of the Lambda function in parentheses. Otherwise, if you have named it, you can use that AMORT function. Here we're back on this AMORT define name page. I'm just going to run through some of these examples of showing these options in action. So first one is that interest only term. If we set that interest only term equal to this cell, we'll change that value in a minute. And we're going to change the balloon payment to that cell, and we're going to choose EPP on that cell there. Right now, the only thing that changed was our loan changed to this equal principal payments, since we have a 1 here to select yes. So you can see equal principal payments, hence the name. If we switch back to 0, we're going to go back to a normal loan that has equal payments, not equal principal payments. Interest only, if we had this 18-month loan with interest only for this first 6 months, these first 6 terms are only going to be paying interest. And then the rest of the loan is going to amortize just over 12 months. So these payments are going to be higher so that we can get this total loan paid off in 18 months. Now, let's say we also had a balloon payment due on month 12. We have interest only still for the first 6 months. And then at month 12, we have a big payment due because we have been paying this loan like it's amortizing over those 12 additional months. But this bullet payment is due after this kind of 6th month after the interest only period. So we have to pay off this entire ending balance here, hence the principal equal to that ending balance. And this loan closes out after month 12. And again, you can kind of play with these optional arguments to change the table. If you don't want headers, you can take that out. It'll take those headers out. If you don't want totals, take that option out. If you don't want things to be rounded, you can take that out as well. So then when you blow these numbers out a little bit more to the extra decimals, you're going to see that they are, in fact, let's see here. I think I have conditional formatting on here. Let's just go ahead and remove that. You can then see those numbers are not rounded anymore. If we switch back to rounding, those numbers are now going to be rounded. So play around with it, see what you think. Let me know in the comments below what you didn't understand, what you like about this, what you think could be made better. Really any comments and thoughts on it. Thanks for watching. Don't forget to subscribe for future videos.